Good afternoon, gentlemen. Welcome to a tutorial about scientific method. And we're going to use this tutorial to introduce us to the scientific method, which is the process that all scientists go through when they are conducting and writing about experiments. And we're going to use this method in class over the next couple of weeks as we conduct some of our own experiments. We'll also use this as a jumping off point to talk about why scientists would want to write about their experiments, what the benefit is to them of that, and then once they've written about and recorded their experiments, why they would share out what they have been working on, share out their results. And so we'll have some conversations in class about why scientists write about experiments and what the benefits are to them and to the scientific community of being able to share what they've been working on. I'm going to go through this scientific method step by step here and review each of these. I'm going to highlight some important vocabulary along the way, vocabulary that we're going to use in class and that you're going to need to be familiar with. As I said, we're going to use this method over the next couple of weeks in class. So we'll start with question. The question is what drives the experiment. It's where the experiment starts, and it's really what you're attempting to answer as you run through the remaining steps of the scientific method. The key to the question is that it is what we refer to as a testable question. A testable question is a question that you can collect some data on, collect some results on, some numbers, and a question that you can eventually, after analyzing those results and that data, answer. The key to a testable question is that it is answerable to some degree, that you're able to, it's able to kind of guide the experiment along, and that everything you do refers back to the fact that it's a testable question, that you can collect some data and eventually work to analyze that question. Two other important vocabulary words embedded in question here in this question stage, which is the first part of the scientific method, is control. And a control of an experiment is part of the experiment that is unchanged. And everything else in the experiment refers back to and is compared to the control. I'll give you an example in a second. The other important vocabulary word within question is variable. Variable is quite different than control. Variable is the part of the experiment that is changed. And so you compare in your analysis stage 5 down here, you are comparing the results of the variable to the results of the control. Let me give you an example. If we were growing plants in class and the control plant was watered the same amount of water every day for the 2 weeks of the experiment. It was watered with water, same amount every day. The variable plants were watered same amount every day, but instead of using water, we changed what we watered them with and instead used lemon juice. So the change would be that we are watering the plants with lemon juice, and we're going to compare how the plants grow watered with lemon juice back to the control with the plants watered with water. Control and variable. The next part of the scientific method is hypothesis. The key to hypothesis is that it's an educated guess. The guess is not random. It's not, it is, instead of being random, it's educated. It's based on some prior experience you might have. It's based on some prior knowledge that you have of whatever you're doing. And so it would need to be what we refer to as an educated guess, okay, not random. You then go through number 3 is running the experiment. Number 4 is the data collection, recording your results and your observations. So the results and the data would be both numbers that you would collect and observations. Observations being things that you notice, things that happen during the experiment that you can't quantify with a number, but that are important to the experiment itself. Okay, and then we move to the fifth phase here, which is the analytics, or the analyzing. And this is where you go back and you look at your data. You go back and you look at how your experiment was run in number 3, and you start to draw some conclusions. And finally, in number 6 is where we're going to write about and explain and eventually answer that question. So we use the analysis that we did in number 5, which used the data from number 4 to come up with, and going all the way back up to the top to number 1, an answer to our question. Okay? And along the way, also looking back at our hypothesis, was your hypothesis correct or not? It's not really a big deal if your hypothesis is wrong. Quite often hypotheses do come up incorrect, and that doesn't make your experiment wrong, or it doesn't make your experiment a failure. You may just have gotten different results than you had anticipated or thought, but that doesn't make your experiment invalid in any way. It's still an important experiment, it's still worth writing about, and it's still important that you explain your results and do work towards answering that question. So once you've kind of compiled all 6 of these stages, you come up with a document. It's called a lab report, or a lab conclusion, which details the question you asked, what you thought was going to happen, how the experiment was run, the data that you collected, your reasoning and analysis and thoughts about that data, and then a final report that summarizes all of those important elements. That is the scientific method. We're going to follow this step by step. We're going to do it a couple times in class for a few different experiments. And this, as I said at the beginning, provides the framework for how scientists conduct experiments. Thank you.